session, the third part of complex numbers, and we're going further with examples, but now I'm dealing with examples of arguments only. Okay. For instance, the first example says that we should find that argument z1, z2 when z1 is -1 and z2 is I. Now, there is an idea that you need to understand first before we can actually take that question, and is the idea that the argument of z1, z2, which is multiplication of the two, is just going to be equal to the argument of z1 plus the argument of z2, basically. Okay, so using this idea, we are going to understand one thing now. This, okay, let me just solve that. Now, looking at this, guys, okay, this idea also applies for principal arguments. Okay, that's what I wanted to say. Now, the argument of z1 is just the argument of -1, and the argument of -1, look at the minus lies on the real part. Okay, so since it lies on the real part, we are going to only consider the part where what do we call this, our cos is positive. I mean, our cos is negative because it has to be -1. So where our cos is -1, it's when we have that our angle is pi. Okay, so I don't know if maybe I should draw that table again, but for the purposes of us understanding, let me do this. Let me have this here, okay, and have this. This is sine, and this is cos. Okay, now when we have pi, and then when we have pi. Okay, I hope you can see that idea that I'm trying to show you here, guys. Now, going back to the question, we are all gonna agree that cos of -1 is equal to, a cos of -1 is equal to pi. Okay, now let us look at the argument of I. Okay, now the argument of I, it's actually interesting. Okay, argument of I is very interesting. It's actually equals to it's equals to pi over 2. Okay, so basically what happens is that we are looking for an angle in sine such that when we put that angle, we get that our thing, it becomes 1, and that angle is given by the angle here, which is just pi over 2. Now, if we look at the argument of z1, z2, which is given by the argument of -i, because -1 times I is just -i, this will be equals to -pi over 2. Okay, this will be -pi over 2. The extension of the sine graph in the negative side will give us that that solution is true. And if you can remember well, let me write this well. Okay, if you can remember well, -pi over 2. If you can remember well, guys, the principal argument should lie between pi and -pi. This is a critical condition for you to know, guys. Okay, now if you look at this and you look at the 2, you see that it doesn't make a lot of sense for us, right? Now here we find that no, our angle of multiplication between the 2 is equal to that. Okay, but we said that we need to have an angle or the argument of that multiplication being the same as the argument of, or the sum of the arguments. Okay, now if we look at that, you can see that the argument of z1 plus the argument of z2 is equals to now pi plus pi over 2, which is equals to 3 pi over 2. Now you can see that the two thing is they do not mix. Okay, now the reason why they do not mix is because of the next rule that I'm going to give you now. Okay, now if you look at what do you call this, positive angles. Yes, I was coming there. Positive angles. Okay, now you are going to see that now this thing that we have here, the argument of z1 z2 is going to be equals to negative pi over 2 plus 2 pi, which this thing correlates exactly to 3 pi over 2. Now this will tell you that the solution that we found initially was true, but because that now we are looking at positive angles, then we are going to introduce the 2 pi such that the angle can be sufficient enough for us to look at it in the counterclockwise or to look at it in terms of positive angles. But as I said, guys, this and this should give you the same solution. As you can view them, as coterminal angles. Okay, now yes, for us to be sure, please check for me sine of negative pi over 2, and please check for me sine of 3 pi over 2. If they're not the same, guys, please do let me know in the comment section such that I can be able to rectify my mistake. Okay, if they're not equal. But if they're equal, then these are coterminal angles. And obviously coterminal angles, as I said, but we only introduce this because we want the solution to be the same and have the condition that we have up here, this condition, to be true. Okay, I hope I make sense on that one. Now let us look at the second one and the principal argument when we have that. Now let us have the solution for this one. The solution, actually I didn't write solution for the first one. Solution. Okay, now the solution for this one, it's different. Okay, but if you can guess this thing correct, according to the laws of exponents, when you are dividing powers of the same base, what do you do to the exponents? You subtract exponents. Now the same idea, the argument of z1 divided by z2 will be given by the argument of z1 minus the argument of z2. Guys, exponents play an important role, but it's all in how you view it. Okay, it's all in how you view it. Now let us continue. Sorry, I got a little bit excited there. Now let us look at the argument of the top part now. The argument of I, we have done it before. Okay, and we found that it was pi over 2. This is where sine is 1. Now let us look at the argument of minus 1 minus I. Now the argument of minus 1 minus I, if you can remember well, the first ever example we did, we got the argument of that, the principal argument of that, and it was given by minus 3 pi over 4. Okay, we can check if that is true, guys. Okay, we can check if that is true. For me to convince you, please check for me, because now the modulus of this one is root of 2, and then with that root of 2 that we found here, we check where both sine and cos are negative, which is the third quadrant, and the third quadrant, this is gonna be true. Okay, so please check it, please guys. Okay, now, or even in that example, but it's fine. Let us not waste any more of the time. Now we do have the first argument and we do have the second argument, and we say that the argument of this thing should be equals to the subtraction of the 2, meaning that the argument of z, which is this, should be equals to the argument of this one, which is pi over 2 minus negative 3 pi over 4, which is pi over 2 plus 3 pi over 4, which this should give me. Now, okay, let me write this down first. 5 pi over 4, because this multiplied by 2's, yeah. Now, this is the solution we're expected to get, okay? This is the solution we're expected to get. Now, the argument of z is equals to this by virtue, by that, by, yeah. Now, looking at the solution that we're going to find here, this solution must meet the criteria that the argument, the principal argument of z should lie between negative pi and pi. Okay. Now let us check what is 5 pi over 4. Okay. 5 pi over 4, it's way above pi. Okay. 5 pi over 4, it's way above pi. Now, what we're going to do is that now we're going to say now the argument, the principal argument actually of I, negative 1 minus I, is given by whatever solution we have there over 4 minus 2 pi. For us to have it in this, what do you call this? Range, domain, whatever that you want to call it, okay? So the solution that we're going to find here is going to be the, oh, let me see. If I multiply this by 4, it's going to be 5 pi over 4 minus 8 pi over 4, which the solution becomes negative 3 pi over 4. Now negative 3 pi over 4 lies in this criteria, then therefore the solution is minus 3 pi over 4. So the logic was because this solution doesn't lie in this domain or range or whatever that you want to call it. Okay, I hope you understand. So let me take another example based on these ones, because like, I mean, the first one is too easy to understand. The second one, well, so I hope you guys are still with me. Let us see for this one, find the principal argument when that is true. Okay, now with this one, solution, guys, I don't want to write down that this rule here. I don't want to write it down again, so let me just continue from that. Okay, so I said we should find the argument of the upper or the numerator, so the argument of negative 2. Now I believe the argument of negative 2. Now check, guys, the argument of negative 2 is just the same as saying the argument of negative 1, because the modulus of this one is 2, and then negative 2 divided by 2 is just negative 1. So it's just gonna be pi. So cos of negative 1 is pi. Now we're gonna do the same thing and find the argument of 1 plus the root of 3i. Now this one is going to be a bit interesting because the modulus is 1 over 2. Okay, basically what I'm saying to you is that we are going to look for cos of theta, which is 1 over 2, sine of theta, which is the square root of 3 over 2, and then the theta value that we're going to have there is going to be pi over 3. Okay, even here it's pi over 3. Okay, these are special angles, so with special angles it's easy for me to find the solution. Okay, it's easy for me to find the solution. So the solution will be just pi over 3. Now, as we know, the argument of z is going to be, let's write it down. The argument of z, which is this whole thing, is going to be the argument of -2 minus the argument of 1 plus the square root of 3i, which this will be pi minus pi over 3, which is 3 pi over 3 minus that. This is going to be just 2 pi over 3. This is the final answer. And according to the rule that the principal argument of z should lie between pi and negative pi is true. Okay, so this one we leave it like that because it lies in this range, this domain. I don't know, it's a range or the domain. It lies here. Okay, and let us look at the last one. Last one is intriguing. It's very nice. Okay, let us go through it. Solution. I'm not gonna write that long, so let us just jump straight to it. Argument of I. Now guys, we are doing the same questions over and over again. Right now I believe that you know that the argument of I is pi over 2. Okay, we've been doing the argument of I in the previous question, and now we're still doing the argument of I. Okay, but if you don't believe, in the previous question we said that the argument of I is pi over 2, so I don't need to convince you anymore. Okay, and then the argument of -2 minus 2i is given by, now I'm going to do the same thing. Now it's going to get interesting because now the modulus here is going to be the square root of 8, which is the same thing as 2 root 2. Now therefore it means that cos of theta is given by -1 over root 2. Sine of theta is given by -1 over root of 2. And clearly, if you can look at this, guys, you know that this will just give us -3 pi over 4. Okay, looking at the thing that is given there, minus 3 pi over 4. You can check it, guys. You can check it. The quadrant where both of them are negative is the third quadrant, and in the third quadrant, this is the angle that is given for them. Okay. Now, the argument of z is given by the argument of I, okay, minus the argument of -2 minus 2i, okay, which is pi over 2 minus -3 pi over 4. Now, this is going to give us pi over 2 plus 3 pi over 4. So you just multiply those terms by 2. This will be 5 pi over 4, which 5 pi over 4 doesn't actually give us this condition to be true. Argument of z lying between pi and -pi. Then therefore, the argument of z will be given by 5 pi over 4 minus 2 pi, which the solution will give me -3 pi over 4, which now this one meets this criteria or this condition. Okay, so if you came this far, guys, please hit the like button, guys. If you have got any problem, please comment below, guys. But for now, thank you very much for coming with me this far, and I hope to see you in the next video. Thank you.